We are about to study an axiomatic system. Therefore, we are going to sequentially construct the subject matter of Euclidean geometry. Before we start, an important point to note is that in plane geometry, we perceive the magnitude of a geometrical object in three dimensions: length, width, and height. There are three undefined terms in plane geometry: a point, a line, and a plane. Think of some location in space. We will call it a point. Because it's some location in space, it has no length, no width or height. A line can be perceived as a geometrical object made of points that has only length, an infinite length. A line has no width or height. At each end of a line, there is a point. A plane is a geometrical structure made of all points lying evenly. It is an infinitely long and infinitely wide flat surface. In the image shown, figure C fits the description of a plane. Figures A and B are not considered to be planes. We are now going to look at defined terms, whose meaning can be explained clearly using the three undefined terms. The term a plane figure refers to a portion of a plane bounded by lines. Therefore, a plane figure has a finite length and breadth. The term a straight line refers to a line whose all points between the two extremities lie evenly. A straight line extends infinitely in opposite directions. The figure on the left shows two plane figures, which are finite portions of a plane bounded by lines. The figure on the right shows a straight line whose all points lie evenly between the 2 points which form the two extremities of the straight line. The term a line segment refers to a finite portion of a straight line. In the image below, a line segment between the 2 points A and B is shown. Two straight lines or line segments in the same plane are considered to be parallel if they never meet each other, even if they are extended indefinitely on either side. As you can see, figure A shows two parallel lines and figure B shows two lines which meet each other when extended to the right. Therefore, by definition, the two lines in figure B are not parallel. The term a plane angle is defined as a figure formed by two straight lines meeting each other. It must be remembered that the point at which they meet is common to both lines. The figure shows two lines intersecting each other at point P, which is common to both lines. The four resulting angles are highlighted in light yellow, pink, light green, and light blue. If a line meets another line at some point, which results in adjacent angles which are equal in magnitude, then we call each of these adjacent angles a right angle. The image shows two line segments PQ and RS meeting each other at point Q, which results in two equal adjacent angles PQS and PQR. Because these two angles are equal in magnitude, PQS is a right angle and so is PQR. Any angle which is smaller than a right angle is called an acute angle, and any angle which is larger than a right angle is called an obtuse angle. Figure A shows an acute angle, and figure B shows an obtuse angle. A polygon is defined as a plane figure bounded by straight lines. Two polygons are said to be similar if they share the same shape. It must be remembered that similar polygons may not share the same size. Now we are going to define the term congruent. Two plane figures are said to be congruent if they coincide exactly when superimposed. The reason why they coincide exactly when superimposed is because any two congruent plane figures share same shape and size. A triangle is a polygon bounded by three lines. An equilateral triangle has three equal sides. An isosceles triangle has two equal sides. And a scalene triangle has three unequal sides. The image shows triangle ABC, which is an equilateral triangle. Triangle DEF, which is an isosceles triangle. And triangle GHI, which is a scalene triangle. A right triangle is a triangle that has a right angle. An obtuse triangle is a triangle that has an obtuse angle. An acute triangle is a triangle that has three acute angles. A polygon bounded by four lines is called a quadrilateral. A quadrilateral whose opposite sides are parallel is called a parallelogram. A parallelogram that has four right angles is called a rectangle. And a rectangle with four equal sides is called a square. So according to these definitions, all rectangles are parallelograms, but not all parallelograms are rectangles. Similarly, all squares are rectangles, but not all rectangles are squares. A parallelogram whose four sides are equal is called a rhombus. Therefore, all squares are rhombuses, but not all rhombuses are squares. A trapezoid or trapezium is a quadrilateral that has only two parallel sides. A quadrilateral with two pairs of equal adjacent sides is called a kite. Now we come to the definition of a circle. A plane figure bounded by a line whose points are equidistant to some internal point is called a circle. This internal point is called the center of the circle, and the constant distance from the center of the circle to the line is called the radius of the circle. You can see these facts clearly in the image shown below. What is the geometrical basis of measuring the magnitude of an angle? To understand that, we must visualize how an angle is formed. A straight line which originates from one point and extends in only one direction is called a ray. The figure shows two such rays, one highlighted in black and the other one blue, each originating from a single point called the vertex and extending to the right. We will call the ray highlighted in black the initial side and the ray highlighted in blue the terminal side. Imagine that the initial side remaining in the same position while the terminal side revolving around the vertex in the anticlockwise direction. This results in angles of various magnitudes, which are highlighted in pink. One complete revolution of the terminal side will bring it back to its starting position. By convention, we say the magnitude of one such complete revolution is 360 degrees. This convention of one complete revolution being equal to 360 degrees comes from ancient Babylon. It is most likely related to the fact that they had 360-day-year calendars. We can draw two lines perpendicular to each other across the center of a circle, thus dividing the circle into 4 equal parts. Since one complete revolution is equal to 360 degrees, this makes the magnitude of a right angle to be 90 degrees. Therefore, the magnitude of an acute angle must be less than 90 degrees and the magnitude of an obtuse angle must be more than 90 degrees. Finally, it must be remembered that when we are talking about the magnitude of a line, we are talking about length. When we talk about the magnitude of a plane figure, we are talking about area. And when we talk about the magnitude of an angle, we are talking about degrees. In summary, we talked about undefined terms, defined terms, and the magnitude of various objects in plane geometry. Thank you for watching.